In this lesson, you will learn about vertical angles. Vertical angles are formed when two lines cross. In this case, the word vertical means that the two lines that form the angles share a common vertex. When I was growing up, the vertical angles were just called opposite angles. They were across from each other, across the vertex, and so they were opposite each other. So I grew up learning about them as opposite angles. They're called vertical angles, and I'll use the words, both words, to mean the same thing. Vertical angles and opposite angles are the same thing. Here we have two lines that are crossing. Angles 1 and 3 share a common vertex. They're opposite each other. They're vertical angles. Angles 1 and 3 are vertical angles. Well, in the same crossing of the two lines, we've got angles 2 and 4 that are also opposite the same vertex. They share the same vertex. They're opposite angles. They're vertical angles. And what's extremely important to remember is that vertical angles are equal to each other. They have the same measurement. Looking at this example again, angles 1 and 3 are vertical angles. They're opposite the same vertex. And if we look closely, they're both acute angles. And if we were to take our protractor and measure them, you would find that angles 1 and 3 are equal to each other. They're vertical angles, and they're equal to each other. If we take a look at angles 2 and angle 4, we see that they're both obtuse angles. And if we take our protractors and measure them, we would see that both angles 2 and 4 would be the same measurement. They would have the same measure. Angles 2 and 4 are vertical angles, and they are equal to each other. Here are two more lines that cross, but they're labeled a little differently. Let's take a look at the vertical angles, the angles that are opposite each other on the common vertex. So we've got angle ATR. This angle here is opposite angle LTM. So those two angles are vertical. We also have angles ATL, and the angle opposite the vertex is angle RTM, this angle right here. Those two angles are also vertical angles. So if I were to list the vertical angles, I would list it this way. I would say the two pairs of vertical angles, ATR, LTM, is one pair. I could write that as angle ATR is equal to angle LTM. They're vertical angles, they're opposite each other, opposite the same vertex, and they're equal to each other. Looking at the other pair of vertical angles, I could say that angle ATL, this one, angle ATL, is equal to angle RTM, angle RTM. And the reason that they're equal to each other is that they are vertical angles. They share the common vertex right across from each other. Here's another example written in a different way. Down here we see that angle DOS, that's angle DOS, this one here, and angle BON, are vertical angles. They are opposite angles, and they are equal to each other. To the right of that, we see angle DOB, that's DOB, this one here, and angle SON, angle SON. Those two angles, highlighted in purple, are also equal to each other. So we have two pairs of vertical angles, DOS and BON, and we have DOB and SON. So we have two pairs of vertical angles that form when two lines cross. Let's take a look at it just one more time. Let's identify this angle here, which is obtuse. It's a little bit beyond 90 degrees. I can call that angle TLK or angle KLT. So I'll write that down. Angle KLT T, and it has an opposite angle, an angle that's vertical to that, and that's this angle here. I could call it HLN or NLH. It's the same angle. So I can call it angle HLN. Now these two pairs of angles are vertical angles. They're opposite the same vertex right here in the middle, and they're equal to each other. They have the same measure. Let's look at the other pair of vertical angles. Angle TLN or NLT, and I'll write that here, angle TLN. And the vertical angle, or the angle opposite that vertex that they share, is angle KLH, or HLK, either way. So angle KLH. Now, this is the second pair of vertical angles, and they are equal to each other. They're both acute angles, and they have the exact same measure. So what happens when we've got two lines that cross, and we know one of the measures? We know that this happens to be 65 degrees. Well, because we know that vertical angles are formed when two lines cross, and vertical angles equal each other, I know that this angle here is also 65 degrees. And the same is true with the other pair of vertical angles. If I know that this angle here is 115 degrees, then I know that the vertical angle opposite it, this vertical angle here, is also 115 degrees. Now, if I combine the two together, this one was 65 degrees, and the angle opposite it is also 65 degrees. Well, when I look at this, I should be able to see that these two angles that are side by side, that form this angle here and this angle there, should equal, what you learned already, should equal 180 degrees because it forms a straight line. So I can write 115 plus 65 degrees gives me 180 degrees. So that's an added bonus, combining what you've learned about straight angles as well as vertical angles. And that concludes our lesson on vertical angles.